Number 46. What is the characteristic color of the flame test for potassium? This is something lab related question that you kind of need to memorize. So this is what I'm talking about, the trivia questions. Um, well, let's tackle it. Potassium, okay, that's K plus. Well, when you do the flame test, which is simply the violet. Okay. And this test is used in the qualitative analysis. Meaning you can test separating technique, and ultimately you want to know what solution you have or what ions you have in your solution. One way to separate the potassium from, for example, sodium is doing the flame test. When you perform the flame test for the sodium, you're gonna get the yellow. So this is for sodium. And the red color is observed when you have lithium. And then the green is observed when you have barium or boron. So this is something you just have to memorize. Okay, so it's a qualitative analysis if you want to review further. Alright, number 47. Which atom has the highest electronegativity? Well, you just have to look at the periodic table, and if you kind of memorize the position of periodic elements in the periodic table, well, you're gonna notice that the chlorine is right below the most electronegative atom, the fluorine. Despite this is weaker than oxygen, and I have to kind of memorize some of them because oxygen has like a 3.5, and when I compare that to chlorine, I know oxygen is higher, but chlorine is still higher than most other elements. It has 3.0, and definitely not the sodium ion. It has very poor electronegativity. In fact, they want to give up the electrons in the neighboring atom. Phosphorus is still far away from fluorine, and also bromine is also far away. So simply it's C. Number 48. In which set are both elements metalloid? Okay, this is something you need to look at the periodic table again. You're gonna notice from the periodic table, starting from boron, and you're gonna see like staircase shape. These are all metalloid, meaning they have a characteristic of both metal and non-metal. Okay, and these two atoms are definitely part of the metalloid. The rest, this is both non-metal, these are transition metal, and these are transition metal as well. So the answer is B. I believe this is beryllium and this is arsenic. Alright, number 49. The silicon oxygen bonds in silicate or SiO2 are best described as polar covalent. Now this is tricky one because a lot of people might relate to carbon dioxide, because silicon is right below the carbon in the group 4 in the representative element. We know from drawing the Lewis structure, this is what we observe for carbon. However, the silicon dioxide is not in the same shape. In fact, contrary to the carbon dioxide, which kinda has its own molecule as a unit, the silicon dioxide has more like a tetrahedral shape. So let me draw that for you. Okay, it has a covalent network. And you can kind of see how it behaves. Alright, it looks like this, and then the bond can go all kind of directions, just like diamond. So it's very strong. That means it also has, the silicon dioxide also has the high melting point and boiling point. So that's what that is. And you might wonder why polar. Well, it has a lot of oxygen atom, which is very polar, has a high electronegativity value. Therefore, D is the most appropriate answer here. Number 50, which bond is strongest? Okay, the carbon and oxygen double bond, the carbonyl is the strongest. The reason is the oxygen is most electronegative compared to sulfur, nitrogen, and simple carbon. Because it's very electronegative, it's going to draw the electron toward itself and creating the bond length between the carbon and oxygen to be smaller, and therefore the shorter bond lengths tend to be harder to break and they tend to be stronger.